Okay, so let's go ahead and take a look at number 7. So there are two ways to solve number 7, one by hand and one on the calculator. So I'll go ahead and show you the way by hand first, because if they ask for exact values, you're going to need to be able to do it by hand. If they ask for approximate values, you can just use your calculator. Okay, so it says solve this equation for x in the interval 0 to 2 pi. So we're only talking about one time around the unit circle. We're only talking about answers that fit between 0 and 2 pi. Because we know we can go around the unit circle infinitely many times. So we don't have all those answers. They've restricted to 0 to 2 pi. So my approach for this problem is first going to be rewriting this as 2 sine squared of x minus 3 sine of x plus 1 equals 0. So all I did in the first step was put the 1 on the other side, and in order to do that I'd have to add to the other side. Now I see there's a trinomial, it has 3 terms. So I'm going to substitute a value in for sine, and then I'm going to go ahead and factor. So what I mean is I'm going to substitute a value in for sine, is I'm just going to write 2a squared minus 3a plus 1 equals 0. The reason I did that, replaced the sign with a, it's just to make it look a little simpler. Okay, I'll go back at the end and replace a with sine, how we should solve it at the very end. So if I go to factor this, I'm going to use the illegal move, where I take the first term and I multiply by the last term. So I get a squared, that first term drops off, minus 3a plus 2, because again I'm multiplying 2 times 1, equals 0. If I factor this, I get a minus 2, a minus 1. We need to see what adds to give us the middle term, what multiplies to give us the last term. Negative 2 times negative 1 gives us positive 2. Negative 2 minus 1 gives us negative 3. Okay? This is still all equal to 0. The last part for the illegal move is to divide by what we originally multiplied by. So I originally multiplied by 2, so I'm going to divide each of these last terms by 2. So the trick here is that we simplify our fractions, and then if there's still a denominator present, we put that denominator in front of our a inside that parenthesis. So for the first one, 2 divided by 2, well that's just 1. There is no denominator left over. So we just have a minus 1. Here though, I'm going to put the 2 back in front. This fraction 1/2 is already simplified. So I have 2a minus 1 is equal to 0. So we're going to use something called the zero product property that basically says if this parenthesis is equal to 0, then 0 times anything else will give you 0. Same thing goes the other way. If the second set of parentheses is equal to 0, then 0 times anything else, no matter what this is also going to give you 0. So what I'm going to do is I'm going to set each quantity equal to 0 and solve. So before I do any of the solving though, I'm going to replace the a with the sign that we had done at the very beginning to make it look a little less complicated. So I'm going to write sine of x minus 1 times 2 sine of x minus 1 equals 0. Again, I'm going to split this up. I'm going to say the first set of parentheses equal to 0, the second set of parentheses equal to 0, and then I'll go ahead and solve each one of them. we add the 1, we get 1 is equal to sine of x. So you have to ask yourself, okay, sine means y, so where's the y value equal to 1 at on the unit circle? Well, there's only one spot where the sine value is equal to 1 on the unit circle. That value is 90 degrees, or pi over 2. So there's our first answer. Now over here we're actually going to get more than one answer. So if we solve this, get sine by itself, we have the sine of x equals positive 1/2. Because again, I'd have to add the 1 and then divide by 2 in order to get the sine by itself. We ask ourselves, okay, where is the y value, because that's what sine represents again, where's the y value equal to 1/2 in the unit circle? Well, there's two spots where that happens. We get x equals pi over 6 and 5 pi over 6. So our three answers, typically we would write them all together in this little curly brace notation. We usually write least to greatest, so the smallest value here is pi over 6, the next value is pi over 2, and our largest value is 5 pi over 6. Now again, I promised that I'd show you a calculator method as well, so let me pull up the calculator and we'll do it that way. Okay, so I've already done a couple of the steps for us already, so I've already plugged in my equation into the calculator, but let me explain why I didn't plug it all into y1. So what I did was I plugged in the left side of the equation, 2 sine squared of x minus 3 sine of x, plug that into the first, and then what it's equal to into the second. We want to know when these two things are equal, or graphically speaking, when they intersect. So it's just a nice little trick. So if I hit zoom now, oh, and by the way, make sure you're in radian mode, and we were doing polar equations before, so you'd have to switch back to function mode in order to enter this in y equals. If I hit zoom, sometimes zoom trig works pretty nice, and it works very well in this problem. Hit option 7. And I get this funky looking graph, and then you see this is the y equals -1 line. So our problem said to only bother looking between 0 and 2 pi, so we know that this is 0 on the x-axis here, and then as we move to the right, it's going to eventually get to 2 pi. So I'm going to shrink my window a little bit. I'm going to look at just right in this area where the two equations intersect one another. So I want to hit zoom box, and then in order to use the zoom box, I'm just going to move the cursor to where I want to start the box, hit enter, and then I'm going to drag a box around what I'm interested in, where the intersections are. Looks pretty good. We hit enter. Now we can get our intersections pretty quickly, and you're going to notice that these are all going to be exactly the same, but they're going to be in decimal form. So another thing I want to point out before we even do that is that we had 3 answers, and we have 3 intersections right here, 1, 2, 3. Now, make sure that you follow the directions and only give the answers that are between 0 and 2 pi. 2 pi is approximately, put this in a different color, 0 to 2 pi is the same thing as saying 0 to 6.28. So on our graph, we only want answers that are up to 6.28. So anyways, let's go back to our calculator. If we hit second, calc, go down to intersect, and now we're just going to scroll over until we get pretty close to the first intersection. Hit enter again, and one more time for a total of 3 times hitting enter. And we get x is equal to 0.523, yada yada yada. If you plug in pi divided by 6, you're going to get this decimal approximation right here. So let's do the other two real quick. Second, calc, option 5 on my calculator. I'm going to scroll over until I get close to the next intersection. Okay, that looks pretty good. Hit enter, enter, enter. And for whatever reason, it jumps to the other intersection over here, so I'll have to go back and do this one again. But anyways, it jumped to this one, 2.6. If you plug in 5 pi divided by 6, that's going to give you 2.6. Let's go back and see if we can get that middle intersection. I'm not really sure why it jumped. Okay, hit enter, enter, enter. Okay, I'm going to try one more time. I'm not sure why it's doing that. I don't know why it keeps jumping like that, so I'm going to try to zoom box around that area and see if I can get that point, because that is our third answer. I'm going to zoom in right where it looks like it's intersecting. Hit enter. Okay, we can definitely see that it appears to intersect, so let's try one more time. Second calc, option 5. I want to get it as close as I can to the intersection. Hit enter again, and I'm going to guess now. Hopefully it's there. There we go. So sometimes you might have to play around with the window in your calculator to get all 3 answers, but there's our third answer. Pi divided by 2 will give you 1.57. Okay. Alright, let's do number 8. Switching gears a little bit. Alright, vectors. Vectors operations are pretty easy. Remember that this word here, magnitude, that just means size. So basically we're asking ourselves, okay, what is the size of this resulting vector operation going to be? So we know that this just means that we're moving a certain amount in the x direction as well as in the y direction. Very similar to graphing points, but we talked about vectors. Basically, they are a force, some type of force, maybe it's pounds or maybe it's newtons, etc., in a direction. So it's telling you that it's in this direction of -2, 4. Not only that direction, but it also gives you a size. So that's what we're going to find here. So anyways, let's do the vector operation first. So 3 times u is -6, 12, plus vector v. Vector v is just 9, 1. -6 plus 9 gives us +3. 12 plus the 1 gives us 13. Magnitude is simply just taking basically a form of the Pythagorean theorem. Square root of a squared plus b squared. So I'm going to take my a and my b value and substitute it into this formula right here. We'll probably do this in our head. 3 squared is 9. 13 squared is 178. If I put those two values together, I'm sorry, gave you the answer. 3 squared is 9. 13 squared is 169. If I put those together, I get 178. And that comes out to approximately 13.3. Okay, so either the exact answer or you can leave it as a decimal. Okay, same thing over here. 4 times u is negative 8. 16 minus 3 times v, so that's 27. 3 times 1 is 3. Negative 8 minus 27 is negative 35. 16 minus 3. So again, we're just in the first terms and then the second terms. 16 minus 3 is 13. So I want to show the work this time because this negative sign out front here kind of messes people up. Make sure when you use our formula, a squared plus b squared, and taking the square root of that answer, make sure that you put parentheses around the negative being squared or your calculator will compute it wrong. Plus 13 squared. That gives you the square root of 1,394. And that's approximately equal to 37.3. That's it. All done.